All right, so real quick, let me go over this worksheet with you guys. So we're learning how to calculate frequency using what's called the wave speed formula or the wave velocity formula. So we call it the sound wave formula. It's really the sound speed or sound velocity formula. And this formula can be used for any kind of wave, a sound wave, light wave, any kind of mechanical wave. We're going to use this formula more next week. I just wanted to introduce you to it, kind of get you acclimated with how it works. So the formula goes like this. The velocity of a wave equals its frequency times its wavelength. So remember, its frequency tells you how many times a wavelength passes a certain point, and the wavelength is the distance from crest to crest. We're talking about sound waves here, so it's more like the distance between compression to compression or decompression to decompression. If you don't know what I'm talking about, you can go back to the first day of sound waves and look at the video from Bozeman Science. So that's our formula, velocity equals frequency times wavelength. So in this lab, you guys are going to be calculating frequency. You need to know the frequency in order to use the online tone generator to play these sounds that you'll be finding. So velocity in this case is like speed. We're talking about the speed of sound. So scientists have studied the speed of sound a lot, and they're pretty comfortable with this number here, 343 meters per second. And that's basically the speed of a really fast airplane, or about 10 times faster than you would drive on the highway if you're going about 75 miles an hour. So that's pretty fast, but it's actually kind of slow in the world of waves, especially when we look at light waves next week. We'll get to that later. It's fast enough, it's fast, but it's slow enough that our ears can kind of discern some differences in pitch. For example, sound waves can travel underwater as well as through solids, and the speed of sound can actually change depending on what medium it's traveling through. So 343 meters per second is the speed of sound through air at sea level at 20 degrees Celsius, which is about 70 degrees Fahrenheit. So, and actually the speed of sound can change depending on your altitude and just the temperature of the air. If the air is warmer, it won't travel as fast. If the air is colder, it will travel faster. So the speed of sound can change depending on what it's traveling through, but we're just going to use this number. This is a good average number, 343 meters per second. Now you guys are going to be measuring your objects in meters. You're going to be using centimeters. So the value that we're actually going to use is 34,300 centimeters per second. So the number seems bigger, but it's the same speed. It's bigger because we're using centimeters, which are 100 times smaller than meters. So knowing that the speed of sound is 34,300 centimeters per second, our formula will actually change. So I'm going to replace velocity with the number that we've talked about here, right in that part of the equation. So same equation, I just replaced velocity with 34,300. Okay, so 34,300 equals frequency times wavelength. So all I've done so far is just to replace that first letter for the value that we know it to be. Okay, now in this lab, you're going to be collecting data for wavelengths, and you're trying to solve for frequency. So we need to rearrange this equation a little bit. Let me clear off my annotations here. Okay, we're going to rearrange this equation by dividing. So when I divide, if I'm solving for frequency, I need to divide both sides by wavelength. So I would do something like, give me a second, sorry. There we go. I need to divide both sides by wavelength. And that way wavelength cancels out on this side, and I'm left with this. Of course, it's much easier to look at this formula because we're used to having the unknown on the left side. So frequency is equal to 34,300 centimeters per second divided by the wavelength. If you didn't understand how I got there, it's okay. You can watch this video again, or we can talk on Zoom or in person. Sorry, I had to take a call. So anyway, what you need to know is that frequency for sound equals 34,300 centimeters per second divided by its wavelength. So for example, if we wanted to know what the frequency of something that had 5 centimeters, we would say 34,300 divided by 5 centimeters equals, and that would work out to 6,680 hertz, which is a pretty high frequency. And guys, use calculators for these. Please don't use long division. I want you to use calculators if you didn't know that already. What you really need to know is that this is your formula right here for today's lab. Frequency equals 34,300 centimeters per second divided by the wavelength, and you will be measuring the wavelength, or you'll be plugging in numbers for W for the wavelength here. I hope that helps. If you need anything, please let me know. I'll talk to you guys later.